Hi everyone, it's Methja from Messages Maths, and today we're going to talk about graph transformations part 1. I'm not sure if there'll be a part 2, I'll just put a part 2 if there's going to be anything special, so that might take a while, and let's go on. Okay, so for any given equation that's average, if you take fx as something, okay, let's take this. First, let's see what happens if you take x minus 1, fx minus 1. So, as you can see, it all goes down by minus 1. Okay? And that's pretty average. And just to tell you, if you take fx plus b or a, okay. Yeah, like let's take k. And take it, it'll add up, every single one will add up, and the graph will go up or down depending on the number k, okay, by k units, okay, on a normal Cartesian plane. Now let's do something a bit different. Okay, let's do x plus k here. Now here what happens is it moves horizontally by the negative k units. Okay, write this down please. For f of f for this, it moves oh wait, let's put a here. Okay, and this moves vertically. Let's replace this with a. Sorry, k. For constant, even though constant starts with a c. Alright, now let's go on to something a bit different, and let's go to f, let's go to kf of x. So let's do that. So what happens is something that for negative k, it also reflects down, it also becomes a minimum function. So a maximum function, it becomes a maximum function. And let me, unfortunately in this case, let me search up what exactly happens. Since even if you know that it moves and widens in accordance to the k, so the larger k gets here, the more it moves up and go down. So let me look very quickly exactly how to put that mathematically so that you might be able to calculate something. There you go. See? It stretches by a factor of c if c is greater than 1, and it shrinks by a factor of c if c is less than 1. Now in this exact case, I'm not sure why it's going up. So let me do it like now. Okay. Okay, now it's not going up. Oh, I know why it goes up. So let's go back to the previous one. Plus 1. So what you can do here for kf of x, what you basically do is you multiply like this. So the intercept also, so you get kc. So you multiply the intercept by a factor of c as well. And that makes the intercept go up by c. That makes it go up by c units, and if it's greater than 1, shrink by a factor of c, which we should try and see. Okay, apparently. Now if it's greater than or less, greater than or equal to, no, greater than 0 or less than 0 or less than 1. Greater than 0 or less than 1. Let's put greater than equal, okay, like this. Let's put k in the middle. Let's put less than equal to. Let's put another less than equal to. Let's put like this instead of like that. 0 is less than or equal to k is less than or equal to 1. If this is the case, it'll stretch by a factor of 1 over c. And if it's less than 0, my theory should be that it should reflect in the y-axis in this case. Now let's take something more simple. It should reflect in the y-axis, and as it becomes bigger, smaller, decrease by a factor of c. So increase by a factor of 1 over c. Okay? So you divide, you basically divide the graph by 3. It might seem a bit weird. So if it seems weird, what you basically do is you multiply the entire thing by the graph. So f of x is multiplied by a factor of negative 2.9, which is pretty simple. So negative 2.9 flips the graph, and you multiply the graph, f of x by a factor of the positive, this section without the negative, or just multiply the f of x by the entire thing, so negative 2.9, and you get, and if you multiply f of x, right, you get this. Now for something a bit different, we go to this. Okay. So to make it look nicer, let's see. Okay, it's the other way around. So in this case, let me check over here. See, if it shrinks by a factor of 1 over k, rather than it shrinking by a factor of c, or stretching by a factor. Shrinks by a factor of 1 over k. Okay? And here it stretches by a factor of 1 over k. Now just to check something, let me check this. That's strange. Oh, I see. It's a vertical stretch. So it shrinks in the middle. Okay? So for a vertical stretch, you multiply each y. Yes, because f of x equals y. Yeah, you multiply y by k. But for the inside, you multiply x by 1 over k. Yes. Actually, no, you multiply x by k. Very sorry, you multiply x by k and get this. Now, let's put some exercises. For f of x equals 2x plus squared minus 3. Okay, so this is to the power 2 minus 3 explain k f n x. Let's remove this to make it easier. Nx plus k. So what will happen here is that the function will move up by k units and stretch horizontally by a factor of 1 over n. Okay? If you do this, what will happen here is it'll add up, it'll move up or down by a factor by, well, you'll add the intercept, the height, each height by k, and then you also, sorry, the other way around, you multiply c over here, multiply 3 by b, and then, so it's cbf plus k. It'll move, the up will be cbf plus cb plus k. Okay, so the intercept times the one outside plus k, and it'll stretch both vertically and horizontally. This one by a factor of vertical by a factor of b, this one horizontally by a factor of 1 over n. And that should end the video. Sorry if I was a bit rough and I looked at Google for a bit of help, but please like and subscribe, smash the like button. I'll promise to I'll actually promise to study a lot more, to make more videos with higher quality, as in terms of teaching. And remember to click the notification bell, watch my other previous videos, like, subscribe for more, and see you next time.